Hello, everyone. Pleasure to be here at the Europe Cloud Summit. My name is Ransi, and I'm super excited to be getting started with the public cloud services and how it can be hardened for better security, right? So, without further ado, let's get started. And this is sort of like my promise for the next 45 minutes or so. And what I'm going to do is I'm going to get started by giving you like an overview of the cloud security and then a brief rundown on the various security services from the three major providers, that is the AWS, GCP, and the Azure. And the shared responsibility model, that's sort of like a very tutored model that's been across all the providers, right? And then dive deep into each of the various categories of the services that we're going to be looking at for hardening. We're going to be looking at the various operating systems that's there in the cloud, the load balancers, the how it can be hardened in terms of the DNS security, and specifically look at the API gateway, some sort of like which is mostly used for the serverless perspective, and then look at the PaaS and the FaaS offerings, that is the platform as a service and then the serverless offerings. All right. So before that, a brief intro about me. I work as a principal software engineer at Sonic Wall in the Bangalore office in India. I've got some years of experience under my belt and also have few certifications from all the major providers. I hold a patent in India for the cloud security around the distributed data storage, and I have particular interest around serverless and containers, and also believe in a multi-hybrid cloud future. So that's why my heart is right. So other than my work, I am the organizer for the GDG Cloud, the Cloud Native Group, and also the AWS user groups, all based in Bangalore, India, and speak at regular conferences at domestic and international. I've won multiple hackathons in the cloud and also been recognized by Google as a community influencer. All right, so enough about that. So let's get started. Let's define what the cloud security is. And just for getting started, I've took this information from Wikipedia, and all of you can read. And I'm not going to repeat myself, but just look at the ones that's been underlined here. And cloud security mostly it just focuses on a set of broad policies, right? It just defines what it is for protecting the technology and the stack that is there, irrespective of whether it's sort of like an application and the IP and all the other things, and the set of controls that just goes into defining all of this. So cloud security or the security in general is basically enforcing those rules and guidelines to ensure and protect what is relevant to the organization is not breached or not accessed to anyone outside. So what that is important is because the IT infrastructure and the landscape has undergone a paradigm shift. And what it actually means is, let's just take back and understand this, because when I started my career in the industry, right, this is sort of like the architecture diagram that the network person gave it to me, right? The big bad world of internet that is just sitting out behind a firewall that is just letting only the good traffic through to the glass house, that is the enterprise, right? And it's just filtering out all the bad traffic. But from this traditional view, it's gone into this, right? The glass house is still there, so the enterprise is still there, but it's just that the all your work, so whether it be like SaaS, PaaS, CaaS, SaaS, FaaS, or whatever as, right? It's just up there with the AWS or and just for kicks, I've put all the three major providers, whether it be AWS, Google Cloud, or the Microsoft Azure, right? So everything and anything is just consumable from the cloud with just a stable internet connection, right? So if that is the case, then we should be thinking the cloud security also a little different from the traditional network security, because the traditional aspects in terms of like ACLs and port mappings and all the other firewall rules, and well, they are definitely relevant, but it would have to have a rethink if you have to do it in a cloud environment, right? So to understand that, we need to understand how the cloud is actually different, and we need to understand the different facets that actually make the cloud. And what it is because the cloud is ubiquitous, right? Because it is reachable from anywhere and anytime and any device, right? Because you cannot cut it out. Even with like a 4G hotspot, it is possible to just access the cloud, so to speak, right? Unless the traditional way. It is highly scalable because with the push of a button, you can do like a vertical scaling or a horizontal scaling, and just spin up instances or in whatever capacity that you actually want. So there is this infinite possibility of scale that definitely is integrated. It's deeply connected with the network that is there. So there is no wall that actually defines what is cloud and what is not cloud. And hence, it is definitely possible for the services which are in your enterprise or your data center to actually talk to each other. So there is this full visibility that is there. It is comprehensive. And what it means is the cloud is basically scanning every byte in and out. So egress or ingress, right? It is definitely there to scan everything, and it is intelligent enough. And I don't know if you remember, right, when AWS started in 2007 with just very handful of services like EC2, SQS, and S3 or something, right? That was that was the cloud, right? But now if you go into the AWS console, you actually need like a scroll bar to see the list of services, right? So that's sort of like the intelligence and the evolution of the cloud that we're actually talking about. So from this typical mindset of moving fast or staying secure, and where the early days of cloud, because you had that joy of logging into AWS and just spinning up an EC2 instance, and then it was just putting a layer of security on top of that, right? And that was the early cloud, right? With the launch of the AWS. But no, from that, it's more about you have to move fast, because that there is definitely no compromise on the agility that is there. But at the same time, you cannot compromise security. So because the bad guys are also moving to the cloud. I mean, obviously they have moved on and they've caught up a lot, because they are always like 2 steps ahead of the good guys, right? So it's not just about putting that layer of security or that SSL or TLS on top of your workload. It's mostly deeply ingrained into your workloads, irrespective of what you actually do, right? Whether it be like your big data or AI or ML or any of your other considered to the traditional workloads, right? So, and the modern workloads like containers and serverless, right? So there's definitely a security that has to be taken holistically to make the workloads in the cloud a much more safer place, right? And to understand what it actually means, the cloud features have to be compared with what are the actual security balances that you need. And obviously, we talked about agility earlier with the infinite amount of possible scale that is there. But at the same time, we need a gatekeeper that actually does the security balance of what is actually permitted and what is not. Yes, it is highly self-serviceable with the cloud. That's the whole idea about it. But that doesn't mean that we compromise on the standards that is definitely there. So we definitely need that. It is scalable. Yes, you can scale up or scale out whatever you want, but that doesn't mean we compromise on the controls that is enforced within the organization. So that should definitely be there. And it is automation. Definitely the whole premise of the cloud is built on this whole automatable infrastructure that is definitely there, where everything is like software defined, and it's easy to access and just spin up the stack and spin it down, right? But that doesn't mean that you let go of the centralized monitoring aspect that is definitely there. So with that background, I want to dive deep into, not dive deep, but just give like an overview of what are the security comparisons that are definitely there from these three major providers, right? And we've put all the three just for the sake of it, right? So let's start with the 800-pound gorilla in the room, and that is the AWS. And as you can see, I'm not going to read, but the main idea is there are these aspects, whether it be AWS or the other two providers, in terms of managing your identity or the IAM, right? And your other traditional stuff like the secrets and all the other things, and the L4 and the L7 protection that is definitely provided with the firewall, the web application firewall. There's definitely a lot of emphasis on how you manage keys, and that is achieved with the AWS key management service, right? And the L4 protection, like sort of like the DDoS and everything, that is definitely achieved with the guard duty and all the other ones, right? And if you go into the GCP, the landscape doesn't change much. There's this definitely emphasis on infrastructure, that is the VM and all the other things, which is sort of like the core cloud, so to speak, right? And then there is emphasis on network security, and then the application security. And as you can see, there is the KMS, which is sort of like a very important piece in managing your keys, definitely there. And then the whole identity, which is being achieved with the cloud IAM and the identity aware proxy and all the other things, right? And even for Azure, pretty much the landscape is very much the same in terms of how you manage your keys and your security center, that in terms of your VMs, the DDoS protection that is definitely there. Please bear in mind that these things are nowhere near complete. I've just picked out the important ones that are there just to build the theme around all the three. So that there is this comparison that is going on between the AWS GCP and the Azure, right? So with that background set, I want to touch deep into the shared responsibility model that is common across. And I do not want any particular provider to be there. So this generic information on what the shared responsibility model will definitely help, right? And if you look at it, there is definitely two aspects. There is security of the cloud and security in the cloud, right? And there is this distinction that is there where you share the responsibility. That is, the provider and the customer is equally responsible for the security. And what does it actually mean? So the cloud is obviously nothing but like a data center, right? So the physical aspect of the security, right? Making sure that the perimeter is actually secure, making sure that you have Cat6 cables in your data center to prevent eavesdropping, to make sure that nobody else enters the server room. So that is security of the cloud, and that is the provider's responsibility. But now what does security in the cloud means, right? To make sure that when you deploy something in the cloud, you have the proper checks and balances. You make sure that no unauthorized ports are open, to make sure that the SSL and the TLS is basically using the proper ciphers and the key exchange algorithms, right? Making sure that you are not unwantedly exposing any of your data in the unauthorized manner, making sure that you have the proper authentication and authorization checks, and that is security in the cloud. And if there is like a data breach happening because of any of those, you are actually responsible. And that is the shared responsibility that is definitely there between the customer and the cloud platform provider. And this is very important as you migrate your workloads into the cloud, right? So with that context, I want to dive into the meat of this presentation, and that is looking at the important aspects where there are these default configurations that needs to be hardened. And just for illustration, there's this castle, right, which is in ruins, and we need to harden it. So this is your cloud infrastructure in all your default configuration, which may not be the most secure, right? So let's try to harden it. So first one, the hardening one, is the cloud operating system. And what it means is the Linux 2, the Amazon Linux 2, and the Google Container Optimized Operating System, and the Cloud Shell is shipped with OpenSSH version 4, 7.4 and 7.5, which is outdated and vulnerable to multiple attacks, right? So yes, this is the vulnerability, this is the CV vulnerability that is existing with the SSH. And if you look at the SSH version that is shipped with the Amazon Linux or the Google Cloud operating systems, you can definitely see that this version is definitely outdated. So we need to basically enhance it for security. And you can see that it's a very old version, close to like about 4 years, right? For at least for the 7.4, right? So how do we upgrade it? The simple solution is we just have to upgrade to OpenSSH 7.8, right? Piece of cake. Well, that might you be thinking, but I have done hundreds of updates of OpenSSH all my life, and this could be just one of the other updates. Well, let's go and behold. So what you do is you do a sudo yum update on this thing for Amazon Linux, and since it's a Google Cloud Shell, it's based on a DPN, and you do a apt-get update on the Google Cloud Shell. And what do you get? So you get SSH version V, and you only get the 7.4. And if you do like a yum list or a list of the sources that's available on the Google Cloud Shell, you can see that it's still the 7.4 version. So what does it actually mean? So it means that you could be as grumpy as you like, but even after you do like a yum upgrade, the version is just not getting updated. So which means the default package managers of AWS and the GCP does not even have like a higher version of the SSH. Well, that's really bad. So now you have to do it more of an elaborate manner. And that is, you have to install all the relevant dependencies, download the latest packages from OpenBSD, which is the custodian of it, extract the contents, compile the package from source, and then install the compile package to update. Whew, that's sort of like a lot of work. What? But worry not, I've got this useful script that's just there. You can just get it from the URL that I've provided over here, and I've also tweeted out uh, the the slide just before this so that all of you can just get this configurations and all of the slides that are there, right? And you run the script in Amazon Linux 2 and Google Cloud Shell, and it will just do all the heavy lifting for you. And if you do that, and if you query for the SSH version, you can see that the OpenSSH has now been successfully upgraded to 8.0, and it's just one less vulnerability in your end. So yeah, so it's time to celebrate, okay? So now let's move on to the second harden, and that is the SSH setting. And what it says is the default SSH settings, that is the ciphers and the key exchange algorithms that are part of the Google Cloud Shell and Amazon Linux, are sort of like deprecated and weak. And they are like a lot of multiple vulnerabilities that are associated with it with respect to the sweet 32 attacks, which are associated with the 64-bit block ciphers, and a lot of key exchanges which are very weak, like the Diffie-Hellman group in SHA-1 and all the other ones, right? So we need to have this changed to make it more secure, to remove all the vulnerable ones, right? And you can actually query for the ciphers and the key exchange algorithms in each of these things, and you can see that these ones that are highlighted are all the old ones or all the deprecated weak ones, and we need to have them removed. So how do we do it? Well, we check for the new ciphers and the KEX after the OpenSSH. So in the first part, we basically upgraded the OpenSSH to the latest 8.0. And if you do like a man5 of SSD config, and you search for the ciphers and the KEX algorithms in the man pages, please bear in mind that this is case sensitive. So you bring up the man page and you search for this, and you get the default ciphers for the latest upgraded SSH version, right? So you take this out, you edit the etc SSD config file, and you add the default ciphers and the KEX algorithms in the preferred manner. And if you restart the SSD service, you should be able to see and on querying the ciphers and the KEX algorithm, saying that this is pretty much the all ones are now removed, right? So yeah, so it's time to celebrate, right? Because it's just two vulnerabilities that are actually down. So that's like a good feeling. So the third one, and this is specifically to the load balancers that are there, and it is for if you look at the load balancer, it is basically shipping it with the TLS 1.0 and 1.1, which have like the weak ciphers and security settings, right? And we need to have them disabled, because the latest one is the TLS 1.2, and we should be making sure that the server or the load balancer that is actually serving the request is only having the 1.2, right? Now, you might be wondering, why do the cloud providers actually do this, right? Why do they even have like a weak settings? Because the cloud providers have to ensure that the clients which are entering the end of life are also supported. So they don't want to end up in a situation that the client, say for example, who somebody is using like a Ubuntu 17 machine, right, or an Ubuntu 16 machine, LTS support, or a Windows XP, which has basically entered the end of life, or maybe like a Windows 7 machine, right? If they try to connect to this load balancer, they should not be denied the legitimate traffic, right? They should still be served the traffic, because they may not have the TLS 1.2 support, right? So that's the thing that the cloud providers should be coming from. But now, if you decide that I don't want those clients to be served, it's up to you to enhance the security by disabling the old ones, right? So that's sort of like the background I want to give before we dive into each of these things, right? So now coming back into the load balancer, we have to make sure that the TLS 1.2, if you do not have legacy clients, is the one that is being saved, right? So now if you do like a scan, you can see that there is this weak ciphers that are actually present with the TLS 1.1 and the TLS 1.2. And all of them have to be removed because they have been proven to be broken, right? So how do we do that? Because you have to force the latest security policy on the Elastic Load Balancer, right? So if you go to the Elastic Load Balancer for the EC2, so this is specifically to AWS, you go to the Listener tab and you edit the security policy. And you can see that the default one is the one that is from the 2016 one, okay? So you have to change that to a more stricter and the recent one, and that is the 2017 policy. Now you select the ones which is having the TLS 1.0 2017, and just for reference, here is like a good handy chart that is there from the AWS documentation. I've given the link below for reference, and you can use that to make sure that the default ciphers are there. So this is like definitely a good handy chart to cross-check your metrics of the supported ciphers, right? Now, if you do like a scan, immediately changing the security policies, you can see that the TLS 1.0, 1.1 have been disabled and only the 1.2 have been enabled back. Okay, so that's good. So hope you guys are fascinated by it and ready to listen to more, right? So we are now down with the 3 vulnerabilities, and now going into the 4th one is the hardening of the DNS. And what it means is the certificates that are generated by the Amazon Cloud Manager or the Google Trust Services, which are managed by Route 53 or the Cloud DNS. So these are the providers from AWS and GCP respectively. Does not enforce the CAA record creation. Now, what exactly is the CAA? Because it's sort of like a mandate that has been there from the IETF to make sure that no other providers can basically issue certificates on your behalf. So if you have the CAA enabled, it basically is sort of like an additional security check to prevent the certificates from being generated. Because with services like free certificates like Let's Encrypt and everything, it is definitely possible to issue certificates for any domain, right? But if you have CAA enforced on these domains that you actually own, and if it is managed by these, it definitely makes sense to enable the CAA record set, right? So this is sort of like an additional check that you can actually safeguard your domain. So how do you do that? Well, in Route 53 for the CAA, it is you have to create this record set. That is, for example, a record domain like example.com, you add a CAA entry by this entry, right? And equivalent entry for the cloud DNS for the CAA record is basically this, that is zero issue pk.group, right? I had to jump through like a lot of hoops to get this actual value, and I've put this all for you folks so that it is very easy to refer and everything, because there is no single place that you can actually go through. I had to look at a Stack Overflow thread and then a Medium article to figure out and stitch all of these together to create this entry, because this is something that I'm speaking from my personal experience, right? So, and if you run this scan, I use a Qualys Online SSL scan, and all of the vulnerabilities that I'm talking about here does not use any proprietary tool. All of them are basically on a free equivalent, and that is the whole idea behind this presentation. I'm not using any vendor proprietary SSL or any security scanning tools. These are the Qualys online scans and a couple of other tools that I've used like Fiddlers and all the other things, right, to get the vulnerabilities that are being detected. Okay, so coming back, if you run the Qualys scan, you can see that the DNSCA policy is now enforced, and it is now there for all of your domains. So yeah, probably maybe let's just go for it's too early to celebrate, but let's just go into the 5th one, and that is the API gateway, right? Now the AWS API gateway is sort of like a fundamental crux in the workloads in the cloud, right? And by default, this is sort of like a very surprising thing, because it provides the support for the TLS 1.2 and the TLS 1.2. So again, we have to go through that all trick that we did with the load balancer. And what you have to do is there's this thing that you actually have to do. So the situation is, in the load balancer, you just had to change the security policy directly in the load balancer. But for AWS API gateway, it's definitely not that straight, because there was nothing that you could actually do to change the security policy directly. Instead, what you have to do is you have to create a CloudFront distribution with the origin domain that is being set as the AWS API gateway, right? And in the AWS API gateway with the CloudFront, you just have to change the minimum origin SSL version policy and then set the storage cipher. So in this way, you will make sure that the API gateway, which is now serving traffic from the CloudFront, is having the TLS 1.2 enforced minimum security policy. So you just have to change from the 2016 to the 2018 one. And it will now make sure that your SSL traffic is definitely serving the traffic from the TLS 1.2. All right. So the next one is the platform as a service, or the PaaS, right? And the offerings from the AWS is the AWS Beanstalk, and from the Google, it is the Google App Engine. And again, this is specifically to the TLS 1.1 and the TLS 1.0. And you can see that this there is definitely going to be an issue if you use the TLS 1.1. So as of beginning of this year, your grade on your certificate would be capped to a level B. So even if you have like a good paying certificate that you've actually purchased from a CA, if you support still the 1.1, 1.1, it will actually be reduced to a grade B. So this is may not be a good security practice, and also it would indirectly impact your Google search rankings and all the other things, right? So we would definitely have to improve this. And you can see that if you do the scan, it has the 1.0 and the 1.1, the traditional, the weak certificate that should definitely be removed. You should only have the 1.2 that should be enforced, right? So how do you actually do it? For AWS Beanstalk, it is pretty easy. You just keep it behind the load balancer and you change that security policy, right? Now for the Google App Engine, what you can do is it offers a little more customization as compared to AWS, and this is more powerful that I feel. And because you can pick and choose the minimum TLS version and also the cipher suits. Here in case of AWS, it was sort of like a policy that was created which had these so and so predefined ciphers. But in Google App Engine, it goes a level below in terms of granularity, and you can pick and choose what are the ciphers. So I felt that was more powerful as compared to the AWS Beanstalk scenario, right? So you choose the ciphers which are actually used, and then you will basically be making sure that the TLS 1.2 is basically served through the right amount of cipher suits, right? So yeah, maybe let's just wait for the end of it to see if I'm the actual MVP or not, right? So the last one is the hardening of the FaaS or the serverless, right? Now, serverless is not just about FaaS, but here I'm talking about the functions as a service. And what it actually means is there are like a lot of security vulnerabilities that could exist in FaaS in terms of serverless if you actually do it, because you could do like a sub-process invocation in from the code, right? You could have access to the /tmp file system, which is there. You can have the function handler to do any number of things as compared to the original one, right? You could get internet access from your SaaS and from your FaaS environments. It's possible, right? And last but not the least, you could have the operating system commands executed at will to do unwanted things, right? So these things are definitely possible with the FaaS. Although now you would think that the FaaS is ephemeral, but within that time frame, it is possible to cause some damage to this actual system, right? So what it actually means is you would say that, hey, I run like this functions within this whole VPC and I am secure in that way. But guess what? VPC is sort of like a network construct that actually is defining this whole definition of your runtime, right? So now you'd say that, hey, I have this access that is there within my data center or the virtual data center, that is the VPC, and my resources that are actually provisioned within this VPC. But is it true that your resources that are provisioned within the uh, VPC will also have access to this FaaS, right? So FaaS should also be provisioned within this SDN wrapper. And now, if there is definitely a functionality break or an elevated functionality that is being provided within this VPC, it's definitely having access to the other resources within the VPC. So just because you think that your FaaS is running within the VPC doesn't mean that it is immune to the other things. If you have other resources, it is definitely possible to talk to the other resources, right? So just don't have that mindset saying that I am good within a VPC. No, being a VPC is good because it gives you a granular access, but it would also have access to that VPC to cause harm, right? So with context, I want to like stop talking and then basically show what it actually means, right? Because I personally am a developer and I want to talk code, right? So this is sort of like a sample exploit that I've written in Python, and I've took Python because it's sort of like the most easiest and the English-like language. And what this program does is it is sort of like a CV filtering app that performs, uh, just looks at the keywords within the PDF file and just gives it out, right? So sort of like a HR use case, right? And the assumption is that the users will provide the legitimate PDF file name. So this is a serverless function that is written in Python. And the developer just assume that all the users are going to be very nice and just going to be providing legitimate PDF, right? But the weakness is that the file name is basically embedded into the shell, which provides direct access to the command invocation, right? So now if you have this weird looking PDF file, it is all relevant, it is all valid characters, and if you give this whole thing, that is, you do a curl command with the text plain and you're posting it into some attack site, right? So what it means is you are dumping all of your environment information into this attack site. So you upload this PDF and bam, you should be able to get all your runtime environments within the cloud uh, VPC that you've provisioned, or the runtime environment on which your FaaS is running, to the attacker side. So this is definitely possible, right? So that is first one. If you do not enforce some sort of like a sanity check within your file names, right? You just gave everything out to the attack side. Now the other one is the subprocess invocation, and this is the that is there in AWS Lambda, and here we have it in Google Cloud Platform. And here what it actually does is you are doing os.system commands. Again, this is Python. I'm just doing a PS output, and I'm just exposing it out into that /tmp file system. Now the /tmp file system is sort of like a temporary file system, but that is write accessible. So you could have any sort of things that is possible to do if you have a vulnerable application that I've just demonstrated earlier, and you could execute any of this command to do anything, right? Now here I've just dumping all the processes just to this /tmp folder, and I should be able to do a ps3 to basically see the process ID of what of it, right? So it's definitely possible in the AWS Lambda and also in the Google Cloud Function. And the other one is the accessing of the function handler of the serverless function, right? So here again, if there is a vulnerability, so this all boils down if your function has a vulnerability. That is the first program that I've just showed, right? The developer is very naive enough to think that the user is gonna input only a valid file names, right? So now exploiting that, you can basically get into the serverless runtime and do all sort of nonsense that you actually would want to do it, right? So here I'm just doing a cat of this whole function that is in the AWS Lambda. It is under /var/task lambda function.py, right? So I am actually getting your whole serverless function source code, and I'm just dumping it into /tmp code.txt. And here in the Google Cloud Function, what I've seen is I've just dictated the whole sample collection. So it just created this write file. I'm writing it and I'm just demoing it how it actually needs, right? So here you are accessing the /tmp to manipulate the contents during the execution time. So all of this is definitely possible with this, and how you actually prevent this is something called as the monkey patching. And this monkey patching is something which is very specific to Python, and there is definitely tricks and tips that you actually do to make it there. So what it actually does is it's a technique to dynamically change the behavior of a program, right, during the runtime, right? And why do we do that? It is basically done to extend the behavior of the modules, classes, or methods without the actual modifications of the source code, right? And these are the various scenarios in which it actually does, but here it is basically to change or modify the behavior of certain runtimes specific activities, right? For in our particular case, we want to change something that is actually being dictated. So what you actually do is you eclipse the existing definition with something else, and you created a new type safe OS.system. So if you look at it, so I've changed the existing OS.system to say something else, and I've created this non-working system that is there. So if the attacker calls the actual OS.system, it's gonna hit the non-working system because the attacker doesn't know what is a safe system. And as a developer, I will use only the safe underscore system parameters to actually invoke the actual commands, right? So the OS, the attacker wouldn't even know what the actual code is, and he would not be able to execute anything. So this is sort of like a patching that is basically done to eclipse the real functionality and to make sure that the current one works, right? So this is one of the monkey patching techniques that you can definitely adopt for your Python programs within the FaaS container, right? So with that, we can see that the hardening is successful, and you can see as compared to the first one when we started, the castle is looking more robust, more secure, and as compared to the default settings, you have altered quite a bit in terms of your compute and your load balancer and your PaaS and FaaS offerings and the DNS and all the other things, right? So, and you removed your weak ciphers and key exchange algorithms and the weak SSL protocols and everything. So with that, it's a wrap. And I'm going to open it up for any questions and discussions, and I'll be able to answer it anything, right? So thank you. It was a pleasure talking again, and see you soon, hopefully in the real world.